back to our YouTube channel. Today we are diving into the exciting world of machine learning. In this video, we'll explore what machine learning is and how it's revolving various fields. So let's get started. Machine learning is a branch of artificial intelligence that focuses on the development of computer programs capable of learning from and making predictions or decisions based on data. Okay, from data we are making predictions and making decisions. The means machine. Okay, machine is making predictions and decisions based on data, and the whole process is called as machine learning. Okay, without being explicitly programmed, machine is able to take decisions and make predictions. In other words, machine can learn and improve from experience. Just like a human being, we learn from our experiences and take future decisions, or we can predict what's going to happen in the future. Just like if you have broken a vase of your mom, and you are predicting that mom will be angry. How you are doing that predictions? Correct. The predictions are based on your previous experiences with your mom. Okay, just like that, how the experience is stored in our brain. In machine too, we are giving them a data is fed to a machine. Machine is like a computer. We are going to code. Okay, so we are giving data to a machine, and that machine, without being explicitly programmed, is able to predict. Yeah, mom will be angry. This is the prediction. It's a prediction of machine, just like us. So how does machine learning work? Well, it follows a general process. First, we have the data. Data is the fuel that powers machine learning algorithms. It can be structured like array. It can be a structured data of like an Excel sheet. Okay, in Excel sheet too, the data is in structured format. It is in the format of tables, right? But in real world, there is not much structured data actually. So where were we? Data is the fuel that powers machine learning algorithms. It can be structured or unstructured. Can come from various sources like sensors, social media, or even online transactions. Okay, social media and online transaction. Let's discuss more about this. How many sensors do you know? Maybe someone know the IR sensor. Okay, maybe someone know the temperature sensor, again motion sensors, right? We know there are many type of sensors present. The data which is collected from the sensors and social media. Oh yeah, everyone know about the social media data. What can be the social media data? Can be likes, comments, shares, or what post you are posting about, your hashtags, etc, etc. Online transactions can be of various types. Okay, for uploading a data or retrieving the data. It can be videos, it can be audios, or it can also be pictures, that is photos, or it can also be financial transactions in the form of tables. It can also be in financial transactions. Okay, we learned about data. This type of data like videos, audios, pictures, photos, like they are actually unstructured data. I will write it here, unstructured data. So about structured data, yeah, you guessed right, the table format, the data which is in numbers, and that numbers are stored in a format of table. It is called as structured data. Nowadays, whatever we are going to do, whatever computer science is doing, and whatever machine learning or artificial intelligence is doing is on the structured data only, as unstructured data is difficult to handle, to process. As we know, computers learn on the basis of maths, zeros and ones. Computer know only one language, that's zeros and ones, which is called as binary language. So we know that the computer understand only numbers, and that too only zeros and ones. So teaching computer to do this, to predict or do decision making, it is necessary that the data which are going to be provided to a machine should be in numerical format. So till now we learned about data, right? Now let's discuss about how to collect it, that is data collection. Once we have the data, we move on to the next step, which is data pre-processing. This involves the cleaning of the data, handling missing values, transforming it into a format suitable to analysis. Data transforming. Okay. Data preprocessing is a crucial step as it ensures the quality and reliability of the data. Okay, we know that the data is going to be a fuel or acting as a food for machines to predict, right? Let's take an example. We want to collect data from people that they like the cake or not. Yeah, it's not actually that much good example, but let's say that we want to collect a data about cake. So we ask some people to fill a form, a Google form for example, where we are going to ask about how you like the cake, how was the taste, how was the color combination, how was the appearance of that cake. Okay, and we given this form to 1,000 people, right? So we got so many forms there aligned with each other. There are thousands of forms. Right. So we picked 2 or 3 forms, and we found that in one form there is only one field is filled, others are just empty. So how will we treat the data? As it's the data is not complete. There are missing, some values are missing, or it can happen that it's a digital format. We were going to convert the files into an Excel sheet. In that Excel sheet, some values are missing, some values are wrongly written, some values are extreme. Like we were asking for a rating from 1 to 10, and the value there is 385. It can happen, right? Absolutely, it can. So, treating data, the missing data, the incorrect data, handling this data and cleaning it, this is the process of this is the first process of data collection. After we collect the data, work is to do cleaning of data. Means there can be some other format, values or numbers, or where we asked for phone number, someone put it ABCDEF. Yeah, it can happen. Not everyone is going to fill the form the way we want to. So first thing we have to do is cleaning of the data. It should then handling the missing values. If something if the value is missing in a table, so what to put there? Should we put a mean value or a zero, or what can we put there? Like for example, student data. Let me clear this now. Okay, we take a new example. Let's take a new example. Student data is there. This is a class report. Okay, it's a class report, and in which there are multiple students. Student 1, student 2, student 3, likewise student 100. Okay, and here are the marks of the student, like subject 1, subject 2, subject 3. Okay, someone got 10, 8, 5, 9, 8, 3. The value is missing here, or 3, 5, 10, missing. Okay, it can happen that the report may be in this format. Okay, we are taking just an example of a class report, as we can just change there, but in actual machine learning, then there can be a data of lakhs of entries. These entries will be in the number of lakhs. We can't every time check, okay, student 1, okay, there are everything is present, okay, it's right. No, we can't, right? So we will apply an algorithm to do the task that we were going to do for. Okay, we will make an algorithm. It will check that if there is a value present or not, and after that, whatever numbers of student we got, yeah, here and here the values are missing, we want to put a new value there. Okay, so what can I put? Okay, so should I just take every value in the subject 1 and take a mean of it, and whatever the mean comes just put there, or whatever just ignore the values, like student 3, okay, your value is missing, you're failed? Can we do that? No, we can't do that, right? So we have to decide what to put if the values are missing, or data transformation. So let's talk about next topic, data transformation. In the data transformation, the data which is in something different format. Let's take an audio example of audio. If a data is in audio, we know that the computer or a machine can understand only numerical values. That numerical values are in zeros and ones. Okay, so we have data in audio format. We want to convert it into 0 and 1. So this transformation, this is called data transforming. So let's talk about next topic, that is next thing is data preprocessing. So data preprocessing. Now comes the heart of machine learning, the training phase. Okay. We feed the pre-processed data. Whatever the data we pre-processing, this data will be fed to a machine. We don't feed the raw data to we should not feed raw data to a machine directly, as it will predict incorrect. So for the right prediction, for the correct prediction, we have or we should to do data preprocessing on the raw data. After we collect the data, the raw data, we should do preprocessing. After preprocessing, we will feed the data to a machine, and after that machine can predict or decide. Okay. So in this phase, we feed the pre-processing data into machine learning algorithm. We convert this pre-processing data is fed to a machine. What is meant by machine? Machine, we are considering machine as an algorithm. No PC or computer can do that. Actual work is done by the algorithm, right? So we will give the raw data, we will process it, and after the pre-processing, the data will be given to an algorithm, allowing them to learn patterns, relationships within the data. An algorithm just their internal parameters to optimize. Algorithms adjust their internal parameter to optimize their performance, and this process is known as training. So raw data processing, after processing it, the process of processing the data is called as data pre-processing. After that, the data is fed to an algorithm, and after feeding, the algorithm learns the patterns and structures of the data, and this process is called as training phase. This till now the process comes under the training phase. This was the initial phase, and this is a training phase, right? Okay, so let's learn more about training phase. Training. Once the machine learning model is trained, we move on to the testing phase. Here we evaluate the model's performance on a separate set of data called as test set. Okay, so new term came, that is test set. Okay, so whatever the data we collected is a raw data. After that, we pre-processed it and put it into a format, and when it is into a format, it is called as data set. Data is a raw. Actually, a raw is an information, and in the structured manner it became data, and the structured, mannered, stored data is considered as or termed as data set. In machine learning, we do split of data. It is a splitting process. We split this data into two forms. First, we use some of the data for training purpose, and we just reserve some data for testing purpose. There are many different ways to do this process. many split it into 8:2, that is 80% for training, 20% for testing. Many 7:2 means 70% for training and 30% for testing. It's depended on the programmer who is programming this. Okay, it's totally on depends on the problem statement, the solution we want to get from that all this machine learning process, and the programmer who is willing to do all these things. Okay, so it's totally depends on programmer. So test set, yeah, we were talking about test. This is test set. We reserve some data from the data set for the testing purpose. It's called as test set. This helps us to understand how well the model can generalize to unseen data and make accurate predictions or classification. We first train a machine on training data, and then just like our exams, we test the machine, how the machine behaves on testing data. Like we are giving data as like this, we are splitting it into 4 parts. It's a training, input, training, output. It is testing, input, and testing, output. While training a machine learning algorithm, first in the training data set, we give all the training inputs, whatever is done. So how, like in whatever the data we have is a past which is happened. It's a history about something. Like for example, a bank transaction. There is many data about, so much huge data about transactions, and it's written that yeah, a customer done this, and because of that the person is a fraud, the person done this, so customer is not a fraud. Okay, likewise we have the data, training input, whatever the customer have done, and training output, that the customer is fraud or not. Okay, all the data we have given for the training purpose to a machine, and after that for the testing purpose we just give the machine a testing input. Okay, we just give a testing input and just observe what our machine is doing with the testing data set. We know testing output. If a machine is predicted that the output is 0, let's say the output is 0, that the customer is not fraud, right? But in the actual data set we have, in the actual testing data set, testing output, actually the customer was a fraud. That means whatever our machine predicted is a false prediction. The machine predicted false prediction. The prediction of machine was false. It was wrong, right? Likewise, we test our machine if machine is predicting false or predicting correctly, right? Let's let's summarize the testing process. We understand the testing in the training itself. I told about the testing too. So let's just talk about testing. How that we have a trained and tested model, we can deploy it in the real world application. Machine learning models can automate tasks, make predictions, detect patterns, and even provide recommendations. They are being used in various fields such as healthcare, finance, transportation, and many more. Okay, so let's learn about the real world applications. But wait, there's more to machine learning. There are different types of machine learning algorithms. For example, we have supervised learning. Okay, supervised learning, where the model has from labeled data to make predictions. The data is labeled data. And unsupervised learning, so they are the types. Okay, unsupervised, where with unlabeled data and aims to discover patterns and structures within it. Okay, the data we have provided to which is labeled like a picture of an apple, which will be labeled as apple, or orange, or a banana. Okay, right. Whatever we are providing to a machine, the data is labeled. And after that, the example, right? Do you remember the example which I just previously gave you about this bank transactions, fraud and not fraud, right? The data was labeled. We given machine the data like for input and output. We have given both input and output, whatever the customer is doing and what is expected, what he had done and what was he. Likewise, we are given labeled data to a machine. And what if we just gave data which is not labeled? Means we are giving just customer behaviors and not actually how the customer was reacting. We just given the data, we haven't given them the labels for the data. So what machine do? Machine actually tries to extract whatever the things are there, it tries to extract it from them. Whichever the information given, just try to extract, like a photograph. Like I gave an example of a fruit, of an apple. So in supervised learning, we have given a photograph and also apple, the word apple. But in unsupervised learning, we just given the photo and not the label. It's unlabeled data, right? We have unlabeled data given to a machine, which is means the machine is learning from unlabeled data, which is called as unsupervised learning. Okay, another exciting type of machine learning. Okay, this is a real world application I was talking about, but actually this the title should be types of machine learning. Instead of writing machine learning, we will use a short form of machine learning, that is ML. From onwards, I will use ML term for the machine learning. Okay. The next type, this was the first, supervised learning. This is second, unsupervised learning. The third is reinforcement learning. It's like a training a model through a reward system. The model learns by interacting with her environment and receiving positive or negative feedback. Like how a child learns. Reinforcement learning, you can understand or remember reinforcement learning, uh, like a child learns uh, whatever, like after guest come at your house, and if your is child knows that if child doing good things, showing manners, then parents will give a reward to child. So child will remember, okay, I behaved good, so I got a reward. And if he behaves not good, his behavior was not good, then parent will give him punishment, and the child will remember the punishment, like a reward and punishment. Child will remember both the things and will take a decision to act according to it, right? Reinforcement learning is also based like this, like a positive or a negative feedback, right? In reinforcement learning, machine do a thing, and after that whatever feedback he is getting, if it's positive, machine will get reward. If it's negative, machine will get a punishment. According to this, reinforcement learning happens. Machine learning is consistently evolving, and new technologies and algorithms are being developed all the time. It's an exciting field to explore, whether you are interested in technical aspects, its application, or even building your own machine learning models. That's it for today's video on machine learning. We hope you enjoyed the introduction to world of machine learning and gain a better understanding of its concept and application. If you found this video informative, don't forget to give it a thumbs up and subscribe to our YouTube channel for more exciting content. Also, let us know in the comments what your topics you'd like to cover in the future videos. Thanks for watching, and we'll see you in the next video.